Eye on the Future video contest winners. Aaron and Ethan Shao, Science in the Field or Lab. A young man walks along a wooded path towards the camera.
When things move, they create waves. We see waves around us every single day.
Split screen. A wooden spoon stirs a bowl of water. A person strums a guitar.
For example, when we move a stick in water, we see water waves. When we play music, sound waves move the air and vibrate our eardrums.
The narrator sits in front of a cell tower. Animated circles emanating from the tower simulate waves.
When we send a cellular message, radio waves carry and transport the information to us. Today, I will explain a new category of waves called gravitational waves.
Diagonal split screen showing two black holes orbiting each other on left and a supernova on right.
Gravitational waves are created when the most energetic and cataclysmic events happen, such as when black holes orbit and merge or when superstars explode.
But what exactly are gravitational waves? How do we know that they exist, and why does it even matter?
Drawing of Albert Einstein floats across a field of stars. Cartoon bubble reads, "I predicted it."
A century ago, Albert Einstein predicted that any accelerating mass should create ripples in the fabric of space and time, moving outwards in all directions. Those ripples are gravitational waves, which travel at the speed of light and squeeze and stretch anything in their path as they pass by.
3 balls, 1 black, 1 yellow, and 1 blue-green, sit on a bed of sand. In stop motion, concentric circles drawn in the sand expand from each ball with many intersections.
The power of the wave diminishes over time, which makes gravitational waves hard to detect. After years of development, these detectors became available in LIGO.
LIGO, Laser Interferometer Gravitational Wave Observatory.
Composed of 2 laser interferometers, LIGO uses properties of light and space to detect gravitational waves.
Animation. Light is emitted from a laser and shines against an oblique semi-transparent semi-reflective surface. Reflected light hits mirror 1, and non-reflected light passes through to mirror 2. Light reflected from the 2 mirrors then passes back through or is reflected by the oblique surface to be picked up by a photodetector. Movement of the mirrors changes the amount of light detected. Video credit Caltech.
We made a simulation to help you understand how LIGO works.
A baking pan filled with yellow gelatin with a laser target card affixed to one end and a mirror at the opposite corner. Student shines a green laser through the gelatin towards the mirror. Reflected light hits the laser target card.
Imagine the gelatin is space-time and the balls are black holes. The laser reaches the mirror and reflects over to the laser target card, representing the photodetector. When 2 objects collide, they create waves that disrupt the laser.
2 balls are dropped into the gelatin far from the mirror. The light moves on the target card.
In LIGO, this disruption would be captured by highly sensitive machines. On September 14, 2015, scientists at LIGO detected gravitational waves for the very first time.
Stop motion animation with 2 small balls on a field of sand, which slowly orbit each other, getting closer and closer. A ball representing Earth sits in the corner.
About 1.3 billion years ago, 2 massive black holes drew together and swirled around each other at very high speeds, then finally collided and merged as one black hole. The collision released a massive amount of energy and sent gravitational waves in different directions.
The 2 black balls merge. Drawn circles representing gravitational waves expand from the merged balls, eventually reaching Earth.
The entire collision took only 0.2 seconds, but it took the waves 1.3 billion years to arrive on Earth. The detected waves sound like this.
It might not sound significant, but the moment was revolutionary. The detection and analysis of the waves not only proved Einstein's theory of general relativity.
Narrator speaks to the camera from a grassy field. Drawing of Albert Einstein. Cartoon bubble, "I told you so."
But it also detected black holes for the very first time. In the past, with light-based observatories and telescopes, scientists could only see the universe. Gravitational waves are allowing scientists to hear the universe as well. With increased sensitivity and collaboration, LIGO could detect more objects and solve more mysteries in space, perhaps even the formation of the early universe after the Big Bang. Maybe it's you or me to discover the unknown.
National Eye Institute, nei.nih.gov/eyeonthefuture.